All right, let's look at the conditionals. All right, conditional is really just the if then statement. So I'll just say if then statement. So it's just a simple implication. So for example, we can say P implies Q, or you can say if P then Q. Right, if part is called the hypothesis. So P in this case is called the hypothesis. And then part is called the conclusion. Right. Then opposite implication is called the converse. So Q implies P, right? And unfortunately, converse is not logically equivalent to the original statement, but it's called the converse, right? It's basically the reverse implication. And a contrapositive is negating a Q and P of a converse. It's so not Q implies not P, right? And this one is actually logically equivalent to the original implication, right? To see that, easiest way is to look at the truth table, right? So let's look at the awful possibility of truth value for P and Q. So you could have true, true, or true, false, and false, true, and false, false. All right, so let's look at the truth value of the original implication. True implies true is a true implication. True implies false is a false implication. And false implies true is a true implication. Actually, this should be false. False implies false is actually a true implication. So whenever hypothesis is false, implication is always true because if part really never happened. All right, so let's look at the converse. All right, true implies true, so that's a true implication. False implies true is a true implication. True implies false is a false implication. And false implies false is a true implication. Alright, so you can see that these two guys have different truth values, therefore they're not logically equivalent. Alright, so let's look at the contrapositive. So in order to do that, we need to negate P and Q. So Q, negation of Q. So true, false, so negate that. False, true, false, true. Alright, negating P, true, true, false, false. So it's gotta be false, false. True, true. Alright, so let's look at the implication. False implies false, so that's a true implication. True implies false is a false implication. False implies true is a true implication. True implies true is a true implication. So you can see that by comparing the original implication, conditional, and its contrapositive, right? They have exactly the same truth values for each case. So you can see that these guys are logically equivalent. All right. And another thing is biconditional. Biconditional is really the if and only if statement, right? And so the notation is this P if and only if, and you can also use the IFF, short for if and only if, Q, right? So this guy is the same thing as implication, both implications together. So P implies Q, and Q implies P. Alright, so let's see, so since it's a if and only if, and if part is the implication this way, and only if is the implication that way. So when you combine it, you get the biconditional. Alright, let's look at its truth value. Alright, so we're going to look at the both implications. So we're going to look at these two guys. Alright, then since this is an and, so both has to be true to get the truth value. So true. So true implies true. False true, so it's false. True false, one of them is false, it's false. And you have a true, so it's true. Alright, so this is the truth value of the biconditional. And biconditional, you really have to have either both true or both false. You can see that true, then you get true. False, you get true. And if it's different, then you get false. Alright, that's it. I hope that this was clear.